Lesson 12.1, Factor Trees, is a review from a while ago when we talked about factoring, prime factorization, and all those things. It was a long time ago. It was way back in Chapter 1, believe it or not. And so what we're going to do is we're going to go over this quickly because this is review, and you do need to kind of remember it and pull it back. And if you can't, you can go back into Chapter 1 and watch some of the videos from there. But factor trees are about factors. Factors are a number that is multiplied by another factor to get a product. In other words, if you take a number, it's a factor, and multiply it by a factor, you get a product. These are the pieces or parts of any multiplication problem. Factor times factor equals product. Now, you may have to work a little backwards on this because we're going to be giving you products. But what you are going to have to do is find the factors for those products. You need to think what number times another number equals that product. Remember our two little tricky ones here. Prime numbers only have themselves and 1 as factors, and composite numbers have more than 2 factors. Now, if you don't remember that, that's way back in 1.6. You could actually go back and check that out, but that's a while back. So here's how a factor tree works. We use 18. Remember, the nice thing about factor trees is it doesn't matter what you start with or how you go. As long as you wind up with the right answer, you'll be fine. We had a big rule, though, here. You're not allowed to use the number 1 because the number 1 gets you nowhere. It does nothing for a factor tree. So you break 18 into two numbers. What times what equals 18? In this case, let's just take 6 times 3. When we hit a prime number, we stop. Once we hit a prime number on one of the trees, we're done. We can't go any further because all we can do is 3 times 1 from here, but we're not allowed to use 1. Look for composite numbers. 6 is a composite number. 6 can be broken down into 2 times 3. 2 is a prime number, we stop. 3 is a prime number, stop there. Pull all these factors down, 2 times 3 times 3, and that gets you your longest factor string, which is also prime factorization. Now, if you couldn't remember 6 times 3, let's say that you thought of 2 times 9. 2 is a prime number, you stop. 9 is not a prime number. You could have 3 times 3. Well, 3 and 3 are prime numbers as well, so you pull all your factors down, and you get 2 times 3 times 3. If I jump back here, look what we got. The same exact answer. It doesn't matter how you do it, just get there. Get to the right answer. 48. Break this down any 2 ways you want. Take a moment, pause the video, and solve this problem. And when you come back, we'll see what kind of factor string you should have had. Okay. 48 breaks down a lot of ways. I'm going with 3 times 16. 3 is a prime number. I stop. 16 is 2 times 8. Oops, forgot my multiplication sign. 2 times 8. 2 is a prime number. I'm going to break 8 down. I'm going to break 8 down into 2 times 4. Stop there. 4, though, can be broken down into 2 times 2. So here we go. We have our factors. 3 times 2 times 2 times 2 times 2. So you should have wound up with 4 2's and a 3 in there. And that's how factor trees work. That's the process for getting a product and breaking it down into various factors.